In this video, we'll use Excel to create an input-output table of a function on an appropriate contextual domain. So we've been given the function h of t equals negative 16t squared plus 500t plus 6. And we've been told that the function gives us the height of an object in feet, and it tells us that t represents the number of seconds that have passed. We're going to start by creating an input-output table. Remember, when you create an input-output table, it's important that you label the columns with the variable name as well as the meaning of the variables in context. So the input variable is t, and that represents seconds after launch. I type that, I click on that cell and hit wrap text. In the cell next to that will be h of t, which represents the height of the object in feet. I click in the cell and click wrap text. Now I have to think about what input values make sense to consider. So t is the input. It represents how many seconds have passed since we launched the object. Certainly t shouldn't be negative. When we launch the object, no time has passed. So the very first value I should put in the table is t equals 0. Now, if you're not familiar with the function h of t and what its graph looks like, maybe you don't have the algebra skills at the moment to determine how far out you should go for this function. Maybe you're not sure when the height of that object would actually hit the ground again. You're maybe just guessing. So if that's the case, we could start by thinking about, okay, if you launched an object in the air, maybe you're just throwing it, maybe you have some sort of mechanical device that's shooting it, like a cannon or something. And so it kind of depends on how many seconds it'll take to land. But certainly I think a good guess would be maybe you could go up to, 10 seconds, 20 seconds. That might be a good place to start. So I'm going to go ahead and put in 5, 10, 15, 20, and let's start there. We can always adjust our inputs if that doesn't seem to be a good set of values. Next, we're going to define the h of t value by writing a formula in Excel that references the input values from column A. So my formula will be equals negative 16 times the t value found in cell A11 raised to the second power plus 500 times the t value found in cell A11 plus 6. Press enter, and then I drag that formula down by putting my cursor in the bottom right-hand corner and double-clicking. All right, so I see at time 0, the object is 6 feet high. At time 5, it's higher at 2106 feet high. At time 10 seconds, it's even higher. 15 seconds, it's even higher. Notice at 20 seconds, it's at that same height. Let's keep going. I'm going to go down to 25, 30, 35. All right, so notice it went up to 3906, still at 3906, and then it's falling downward, and suddenly it says the function value is negative. Let's go ahead and make a graph of this and just make sure that you're clear on what's happening here. I go to Insert, the Charts area, I select the pull-down menu, and I select Smooth Line. We see along the horizontal is our seconds, because that's the input. Along the vertical is the height of the object. It starts here at 0, and it gets higher and higher and higher. It reaches a peak, and then it gets lower and lower and lower, and it would hit the ground right here, and then it would be negative heights, which doesn't really make sense unless you had like a hole in the ground that it fell into or something. But notice that it makes sense that we would say this is the starting value that makes sense in context, and this is the ending value that makes sense in context. All right, let's go ahead and just label the graph axes first before we continue. I'm going to click the plus sign, axis titles. The input axis is t, time since launch. That's in seconds. The output is h of t, which is height of object. That's in feet. Okay, so now we want to find the domain in context. We said a moment ago that it makes sense that this would be the lowest point that we should consider that makes sense, which we already know is 0, 6, corresponds to this point in the table. We also said that it's this point over here that should be the last point that we consider. So how do we find this last point? You'll notice that it's an x-intercept on the graph. That means it has a y value, an output value of 0. The h of t value is equal to 0 at that point. So we can come on over here to Excel table, and we can force Excel using Solver to find that point for us. I go to Data, Solver. I'm going to set the objective cell to the Y value cell, so that's the B18 cell. We want it to equal a value of 0 by changing the X value cell, so that's cell A18. Click Solve. It forces the change. And so now this is really 0. It's just Excel's rounding a little bit. So now we know this is the point 0, 6. That's when it was launched. It was 6 feet high. And then it gets higher, 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 reaches its peak, and then falls, 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 and hits the ground again at 31.262 seconds. So the domain in context is the t's that span from 0 up to 31.262. The way we would say it is, the t's you can plug into this function that makes sense in reality are t values from 0 seconds up to 31.262 seconds.